So this paper has to be used with all the classes, and it's shaped just like what you're working with. So the first thing is you have your petri dish, and we don't want to use the top. We're going to use the bottom of the petri dish to set up. And we're going to set up just like this diagram here. These solid circles represent bromothiamyl blue, and then we're going to have our whatever substance we're working in the center by itself as a control, and then we're going to do different reactions on the side. So in this case, we're going to test aluminum. So I'm going to get my bromothiamyl blue, and I'm going to set that up first. And so boom, and it's just a drop. And the aluminum and the copper will be run the same way, same substances. So we're going to take and use your forceps, and I'm going to take my little pieces of aluminum, and I'm going to put one in the center, and then one here, and if you wanted to, you could put the solutions in first and then drop your aluminum onto each solution carefully, or you can do the aluminum first. Either or will be just fine. But use your forceps because it'll make it easier to get them in there. Once you have that, we are going to follow our instructions. And so the very first one will be NaCl. And this will be all written up for you. So in block A, I'm going to put a few drops of NaCl. And then and B is to be silver nitrate. Okay, and then we're going to do HCl for C. Be mindful of the edge of the petri dish. As you see with the silver nitrate, it ran a little bit, and we want to try not to do that. And then we're going to have for D, KBr, which is potassium bromide. And then E will be sodium hydroxide. And then F will be nitric acid. And so as I said, this is the same instructions for copper, except you're using copper. And once you have that done, you're going to place the lid on top, and you're going to let that sit and react. C, which is over here. And then we're going to add starch. And that's going to go into position D. We're going to add starch two different places. So we're going to have it in position D. But then I'm also going to place it in position F because I'm going to combine it with something else. So let's go ahead and just put it there since we already got the pipette out. Okay. And then we have, I'm going to add in hydrogen peroxide into position E. And then I'm going to be adding hydrogen sulfide to position F with that starch. And now I'm going to add potassium iodide. Place in the center as a control. Then we're just going to add a drop. You can add a second drop if you'd like. Some of these reactions happen pretty quickly. And just as we did before, we're going to place a lid on it and wait for a reaction. Iodide to the control center. And just like I did the other one. So we want to see if this is a similar reaction to what we got with potassium iodide or different. Put a lid on it and wait 10 to 15 minutes. And again, the center is there for control for the experiment. Okay. And on our very first spot A, we're going to place copper sulfate, which is your blue liquid, about 2 drops. And then hydrochloric acid will be in spot B. And then spot C will be potassium chloride. C's on this side. And then spot D will be strontium chloride. And then E will be sodium hydroxide, which is a base. And then the last spot will go to barium chloride. So now that we have our solutions in there, we're now going to take care of our metal. So we have zinc. I'm just going to try to get smaller pieces. So, and try not to get your forceps down into the liquid. So you may have to work with some things here. I'll put one in the center because again, that's our control. And then we're watching for color changes, and we're watching for any kind of indication there's a reaction. And just like we did before, we're going to place a lid on top, and we need to let that react for about 15 to 20 minutes. And so now I just got to get my tin in there, and as before, we're going to need to use forceps to do this. And we're just trying to see if there's something, if we get a reaction or not, if there is any kind of reaction. And then we're going to try to make sense of why or why not there's any reactions. And as before, we're going to need to let that sit and react before we go forward. Okay, so again, you're going to cover it and let it sit for 10 to 15 minutes. So then I'm going to place in position A will be lead nitrate. Position 2 will be nickel nitrate. In position C, we have aluminum nitrate. Position D will be lead nitrate. And I did my dots really poorly there, so we'll have to adapt. Position E will be copper nitrate. And then the final position will be calcium nitrate. Okay, once we have that, then we're going to add our potassium bromide. So again, we're going to put some in the center. And I'm just going to give it another set of drops. And then, just as we've done before, we're going to let this sit for a little bit and wait and see what happens. So I've already preset it up, kind of got off a little wompy with the bromothiamyl droplets. But we're going to drop our calcium into each one of these. And then, just like we did with the other one, there was a nice, ooh, look at that reaction. Okay, we're gonna let that sit and see what kind of reactions we get with that as well. And as always, cover it about 15-20 minutes. Potassium chromate, we're gonna put our control in. And then 1, 2, we're gonna dot up and see if we get any kind of reactions. And as before, we're going to place a lid on it, let it sit there for about 15-20 minutes, and we'll see if we have any changes in our results. Put it in the control center, and let's see what we can get here. And then let that react. We're going to put a lid on it. 15-20 minutes. Some takeaways from your lab. Some reactions are clearly more exciting than others. Sometimes it looks like we didn't get a reaction. And sometimes the bromothiamyl blue didn't really change much. And you know what? That's learning. So the point of this week is to look at some things, observe, and try to draw some conclusions about what we're seeing as far as reactions. Which ones are reacting, which ones are producing something, are they producing gases, which is what you're seeing when you see the bromothiamyl blue change, or is it just a reaction within that little area that it's working in? Okay, and I'm hoping that you start drawing maybe some conclusions about this, and hope you enjoy learning. Live long and prosper.